9.1 has to do with linear and nonlinear systems of equations. We've solved linear equations before. We really haven't spent time solving a nonlinear system. For instance, a parabola and a line. You know, it's possible that a line goes through a parabola and hits it twice, right? It's possible that a line touches a parabola once, a tangent line, or it's possible that a line totally misses the parabola. So we're going to do linear and nonlinear systems. I don't think I saw any systems that were nonlinear and nonlinear. Okay. You know, sometimes the camera gets drunk. Hi. Okay. Okay. He got lost. So today we're going to talk about solving systems by substitution and by graphing. I don't want Cocoa Puffs on my floor. So here we go. Substitution. Do y'all remember substitution? This is a system of linear equations. This is two lines. To solve a system of linear equations, do y'all remember what to do? Using substitution? What do y'all remember about substitution? Okay, 9.2, we're talking about elimination. That's where you're going, I think. Okay, that's not substitution. That's 9.2. Substitution was something else. What did we do with substitution? Yeah. I mean, mathematicians aren't very fancy with their naming things, right? Substitution means you substitute. Yes, yeah. So here's a system. So the solution of the system is an ordered pair that makes both equations true. Solving the system by substitution, and y'all might remember when I write the word substitution, do you remember I kind of wrote it differently? Do you remember that at all? You remember me writing it that way? And what was SBS? Side by side. So when you're solving the system using substitution, if you want them side by side instead of stacked on each other, you work with one equation for a while, then the other equation, and back and forth, right? So to solve this system, I would write side by side, 2x plus y equals 5. That's one system, or one equation. The other equation is 3x minus 2y equals 4. And Sean was right in that to use substitution, I need to get one of the variables by itself. So looking at these two equations, which variable and which equation would be the easiest to get a variable by itself? Because that's how we solve the problem. Why are you asking why? Which variable y? There's two of them. The left one, right? Because it's already what we call singular, right? A singular variable is a variable that has a coefficient of either 1 or -1. It's easy to get those by itself. So the first equation, to get y by itself, I would simply subtract 2x from both sides, correct? That gives me y is equal to -2x plus 5. Yay, y is by itself. I know what y is. What do I do with that y? Substitute that into that second equation, which gives me 3x minus 2 parentheses. I'm replacing y with -2x plus 5. Is this coming back to you? Memory's coming back? Okay, equals 4. Okay, and now let's work with this guy for a while. Distributing the -2, I have 3x, -2 times -2x plus 4x, -2 times 5 minus 10 equals 4. I will combine the x's on the left side and add 10 to both sides. Y'all okay with me doing that in one step? 7x equals 14, x equals. And now that I know what x is, I can take that and bring it back over. And this is why we write them side by side, It's so we can go back and forth between the two equations and it just flows really nicely. So y equals 1. Okay, -2 times 2 is -4, -4 plus 5. So the solution to this system is a point. The solution to this system is the point 2, -1, right? X comes before y, which means if I took that answer and plugged it into both equations, it's going to give me a true statement. Yeah, it's clearly a positive 1. Okay. So 2, 1 is the solution. Got it? Moving forward. Here they are. They worked it out. Check it. Plug it in. Okay. So the method of you will study 4 ways to solve systems of equations, beginning with substitution. Substitution is one way. Another way is graphing. Another way is elimination. Another way, we're going to use matrices. So those are the 4 ways we're going to look at. So right now we're looking at substitution. So here's the steps. Step number 1, solve one of the equations for one variable in terms of the other. Number 2, substitute that expression into the other equation. Solve it. That's step number 3. Back substitute. That's step number 4. 5, check the solution that satisfies the original equations. That's it. The term back substitution implies that you go backwards. First, you solve for one variable, and then you substitute it back into the equation to find the value of the other variable. So we're just going back and forth. So back substitute. Okay. Here's a system. We're going to solve it. It tells us to use substitution. So because it's substitution, we're going to write the equations how? Side by side. X plus y equals 4. X minus y equals 2. Which variable and which equation would you like to solve? The left y? Okay. I would have done the x on the right, but that's cool. You said the left y, which means I'd have to subtract x from both sides, right? Subtracting x from both sides gives me y equals -x plus 4. Can I do anything else with that equation? Nothing else? So I'm going to take that value and plug it into the other one. So I have x. Be careful here. This is a minus y. So it's minus. I'm substituting for y. So always use parentheses. I've told that to you many, many, many times in the past. So I replaced y with -x plus 4, and it's in parentheses, equals 2. Distribute the negative sign. -x plus x minus 4 equals 2. Bless you. 2x equals 6. X equals 3. Take that value, bring it over here. Y equals -3 plus 4. So y equals 1. So the solution to this system is 3, 1. Check it. 3 plus 1 is 4. 3 minus 1 is, does it check? Your homework problems aren't probably going to be this easy, right? But the concept's the same. This is beautiful. Okay, moving on. The equations we just did were linear equations. That was 2 lines. Remember, there's 3 possibilities. 2 lines can either touch once, they could never touch because they're parallel, or they could touch infinitely many times because they're actually the same line. Okay? So what if one of the equations is not a line? Can we still use substitution? And the answer is yes. Here are 2 equations. We're going to solve this system by using substitution. So because we're using substitution, we write the equations side by side. 3x squared plus 4x minus y equals 7. 2x minus y equals -1. Which equation would you like to solve and for what variable? Okay, the second equation, the linear equation, solve it for what variable? Okay, get y by itself. How would y'all like to do that? Subtract 2x from both sides. -y equals -2x minus 1. Change all the signs. Y is 2x plus 1. Okay. If I was to graph y equals 2x plus 1, what's it look like? It's a line. If I was to graph this equation, 3x squared plus 4x minus y equals 7, what's it look like? Parabola, right? Okay, so now that I know what y is, I'm going to take that value of y and plug it into my first equation. 3x squared plus 4x minus, I'm subtracting y. The value of y is 2x plus 1 equals 7. Distribute the negative sign, 3x squared plus 4x minus 2x minus 1 equals 7. Next step. Combine like terms. 3x squared plus 2x minus 1 equals 7. Do not add 1 to both sides. There is no y. What does this look like? It looks like a quadratic. How do you solve quadratics? Set it to 0, right? So to set this thing to 0 means I need to subtract 7 from both sides. Okay, so subtracting 7 from both sides gives me 3x squared plus 2x minus 8 equals 0. And this has to be factored, or quadratic formula, or whatever method you can use. How many different x's might solve this? It's a quadratic. It's a quadratic. How many solutions can there be to a quadratic? 2, right? Okay. How would y'all like to factor this? Illegal math? Y'all remember doing illegal math? Y'all remember doing illegal math? Let's factor this using illegal math. I'm going to take that 3 and multiply that -8 by 3. Okay? So I've got x squared plus 2x minus 24 equals 0. Now keep in mind, I took my constant and I multiplied my constant by 3, which means here in a minute, I'm going to have to unmultiply by 3, which means divide by 3. Okay, so we're going to hold on to that for a minute. I need 2 numbers that multiply to -24, but add to 2. Product of -24 combine to 2. What are those 2 numbers? Not -6 and 4. -4 and 6. -4 times 6 is -24. -4 plus 6 is, okay. So I'm going to factor this. Keep in mind, we said -4 and 6, right? So that's going to be x minus 4, x plus 6. How are we doing? Okay. But if you foiled this, x times x is not 3x squared, is it? Okay. So what we need to do now is fix our illegal math. I'm now going to take that 3 that I multiplied a while ago. I'm going to take that 4, divide it by 3, take that 6, divide it by 3. Does 4 over 3 reduce? No. 4 over 3 does not reduce. So I'm going to take that 3 and pull it to the front and write 3x minus 4. Does 6 divided by 3 reduce? Reduces to x plus 2 equals 0. Folks, it's factored. Okay. So what values of x make this equation happy? Not -4 and 2 at all. Set each of them to 0. 3x minus 4 equals 0, or x plus 2 equals 0, which means x equals 4/3. X equals -2. I now have to substitute both of those into the other equation. Okay. So I have two situations. If x equals 4/3, I have y equals 2 times 4/3 plus 1, which means y equals 8/3 plus 1. Y equals 8/3 plus 1 is 11/3. The other solution is x equals -2. So y equals 2 times -2 plus 1, which gives me -3. Okay, so my two solutions are, one solution is 4/3, 11/3. The other solution is -2, -3. Yay, yay, yay. Fun stuff. Now I just hope y'all didn't mislead me and we got it right. Moving on. 4/3, 11/3, -2, -3. Okay. Next slide, I think we're going to talk about. Can we go back again? I want to go ahead and solve this equation by graphing it. Okay. Now, in order to graph these, we have to have y by itself, correct? Okay. So if we take that first equation, if I was going to get y by itself, I would add y to both sides, subtract 7 from both sides. Y'all with me? Doing that, equation 1 becomes y equals 3x squared plus 4x minus 7. Am I right or wrong? Y'all good with that? Now, can you plug that into your y equals on the calculator? No problem. Okay, equation 2, solve for y. What do you get? Y equals, we've actually already done it, right? Okay, so y equals 2x plus 1. Okay, break out the handy dandy calculator. The first equation was 3x squared. I don't remember the rest. Help me here. Second equation was? Okay. Very good. If I graph that, do you see a line that goes through the parabola twice? Okay. What is it called where a graph crosses another graph? What is it called when a road crosses another road? An intersection. Okay. How many intersections do you see? There's 2 solutions. Okay. I want to calculate the value of those intersections. So look above trace. What's it say? Second calc. What do I want to calculate? Intersection. Okay. 3 questions. Question number 1, what's the first curve? Look up at the top. Is that one of the curves? Yes. Enter. Question number 2, second curve. Did it change on us? Is it now on the second curve? Even though it's a straight line, it's always called a curve, okay? Is that the second one? Enter. Now, here's the next piece of it. Why does it say guess? Because there's 2 answers, right? So in order to do this, I have to go through this process twice. So currently the cursor's right there. Which solution is it closer to? The one on the right or the one on the left? Okay, so if I press enter right now, it's going to give me this solution. If I want this one, I would have to move to the left to get it. Okay, so I'm just gonna, I don't care which one I get first, I'm gonna press enter. That solution is located at 1.33333333 and 3.666666. Is this 4/3? This is 3 2/3, right? Which would be 11/3. Okay. To get the other solution, I would go through the same process. Second calc, intersection, curve number 1, enter, curve number 2, enter. But now I need to move to the left. Is that close enough? As long as I'm closer to this intersection than that intersection, this is the one that's going to give me. Press enter. That solution is at -2, -3. Graphing good? Okay. So if they're nice numbers like this one, that's nice and neat for you. If it's ugly numbers like this fraction, you might struggle a little bit using the calculator, especially if they're ugly fractions. Okay. Questions on graphing? Okay. I did this a little out of order because that was an ugly problem. I wanted to work on it a little bit for graphing instead of the one coming up. Okay. From example 3, we had a system of 2 equations with 2 unknowns. It can have exactly 1 solution. It can have more than 1 solution. It can have no solution. By using a graphical method, you can gain insight about the number of solutions and the locations by graphing each equation on the same coordinate plane. The solutions to the system correspond to points of intersection of the graphs. Here are 3 examples. The first one has intersection at 1 point. The second one has an intersection at 2 points, and the third one has no solution. And you can see that easily on the paper. You can spend a lot of time trying to use elimination to find out that there's no solution, or substitution. As long as you type the equations in correctly, you know, you can save a lot of time by saying, oh, these things don't touch. You might have to zoom out sometimes. You might have to zoom in sometimes. Y'all comfortable zooming in and out on the calculator? Okay. Yeah, what about this? Have fun doing this by hand. Substitution. Y equals natural log of x. Well, y is all by itself. Great. Let's take that y value and plug it into the other equation. X plus natural log of x equals 1. Yeah, I don't know how to solve that. Okay. So this would definitely be a candidate for graphing. Simple. Take that second equation, get y by itself. The first one already is. Plug them into your calculator. Calculate the intersection. These 2 graphs intersect at the point 1, 0. You can take the values 1, 0, plug them into each one to check your work. How important is checking your work if you did it by graphing it on the calculator? Do you think checking your work is necessary? If you plug the equations into the calculator and calculate the intersection, probably don't need to check your work. Okay. Work smart, folks. Work smart. This talks about the fact that solving x plus natural log of x equals 1. Yeah, that's going to be difficult to do with what we know in algebra right now. It's possible, but let's not go there. Okay, word problem. The total cost C of producing X units of a product typically has two components. Anytime a business does something, they have startup costs, they have cost of materials, they have cost of labor, right? Then you sell the product, now you're getting income. So that's what you're looking at. So you've got cost per unit, and then income. Break-even point. What happens at the break-even point? You make nothing. Did you lose anything? No. All the money I spent, I got it back. All of my employees are happy because they got paid. I paid my employees, but the man didn't make any money because I broke even. Okay. The break-even point is going to be the point of intersection between cost and revenue. So cost might be increasing, revenue is increasing. The break-even point is where the two lines cross. And I'm just going to talk through this problem. I did not erase it. I don't think I erased any of the pieces of it. So a shoe company invests $300,000 in equipment to produce a new line of athletic footwear. Each pair of shoes costs $5 to make. They sell each pair of shoes for $60. How many pairs of shoes do we have to sell to break even? Making up $300,000 is going to be a lot of money, isn't it? Lots of shoes. So the total cost for this company to make these shoes, the cost per unit is what? $5 times the number of units. Do we know how many units we're going to make? That's a variable. Do we know our initial cost, our startup cost? It is 300,000. So my cost equation is C equals 5x plus 300,000. There's one equation. Can you tell me what the revenue equation is going to be? How much money do I make? R equals. It's very simple. That's it. The revenue is 60x, right? How do I break even? Cost and revenue have to be equal to each other. Does that make sense? Let's move on. The revenue equation, the total revenue is R equals 60x. Because the break-even point occurs when R equals C, we can change R equals 60x to C equals 60. Because if the cost equals revenue, right? Which means my two equations now are C equals 5x plus 300,000, C equals 60x. How would y'all go about solving that? How? Plugging them in and graphing it. Is that going to be way off the screen? Okay. Would this one be easy to do manually? Why? How can we do this one manually? Yeah, do y'all remember this property that looked like this? If A equals B, B equals C, then A equals C, right? I remember what that was called? Transitive, the transitive property. So if C is equal to this mess, but C is also equal to this mess, what does it tell you about the messes? They equal each other, right? So 60x equals 5x plus 300,000. So 60x equals 5x plus 300,000. Subtract 5x from both sides. Divide both sides by 55. And we find that it's going to take about 5,455 pairs of shoes to break even. So what happens if I only sell 5,000 pairs of shoes? I'm losing money, right? What happens if I sell 6,000 pairs of shoes? I'm profitable. Another way to view the solution, example 4, is to consider the profit function. Profit is equal to revenue minus costs. The break-even point is when profit equals 0, which is the same thing as saying R equals C. And that is the end of 9.1, folks.